All right, guys, we are back. This is Mr. Leisman. I'm going to be with you for the first three videos. This is 4.1, Introduction to Radians. This is our first basic introduction to trig here. You guys missed out on this from from Algebra 2 honors last year, so this is definitely something that we are going to kind of focus on. There's just one review question here. I'll talk about number 2 in just a minute. Just take your couple of minutes to work that one out, and I'll be right back. Pause the video. Okay, the answer should have been x equals 1 and 6. Those would be your two roots that you would be using to solve for x. The second one is saying there are how many radians in a circle? Well, I didn't know if you guys would know that one because you didn't talk about it last year. There are 2 pi radians in a circle, and we will talk about that as we move forward and where this comes from and why it is what it is. Our goal today, we're going to be talking about converting angles from radians to degrees and vice versa. We also want to be able to find the arc length of a circle and then describe the meaning of a radian measure. So, looking at this idea of trigonometry. Trigonometry is basically, I'm going to say angles and measures. I would normally say triangles and measures. Trigonometry really comes from the word, it's basically 2 words and it's meaning triangle measure. We do talk a lot about angles and then the measures of those angles or the measures of side lengths, arc lengths, things like that. In terms of what we're talking about in terms of angles, we're talking about an angle can be measured in either degrees or radians. Now, standard position of an angle. Its vertex is at the origin and its initial side is running along the positive axis. So when we talk about standard position and a positive angle, we might take a look at something that looks similar to this. So here's my coordinate plane, my axis. In this particular case, we would have the starting position, or what we call standard position, would be running along the x-axis right here. That is standard position. Emanates from the vertex, and it's along the positive x-axis. And then we would have something called a terminal side. So terminal side would be something maybe like this. So let's say here's this particular piece. Here's our angle measure right here, and it is positive. This would be considered the initial side, and this would be considered the terminal side. We would go in a counterclockwise motion. So we're going to go counterclockwise. This would be considered a positive angle here. And then obviously if we were doing this for a negative angle, we would have something that looks like this. And we would start by being along starting at the vertex, and the vertex is at the origin, running out this way. And then a negative angle would be measured in the opposite direction. So it would be clockwise. And let's say here's our angle measure, and this thing would be negative. And it would be in a clockwise movement. A quadrantal angle, this would be an angle whose terminal side will lie on the x or y axis. So you would have another picture that looks something like this. And you would start by saying here is the initial side, and it maybe would just do something like this and go here. That would be considered a quadrantal angle. In this case, 90 degrees. So the big question here for us when we're talking about this stuff, what is a radian? And the best way to understand the measure of a radian is to think of the meaning of pi. What is the meaning of pi? Well, if we're looking at a circle, we know we have a couple of different measures. We have a circumference measure, and circumference can be written one of two ways, pi times d, or we can say it is 2 pi r. Either way, those would give us kind of this idea of going all the way around the circle. We also have area, but that's not really what we're talking about right here. So if we consider this to be the case, here's the center of our circle. And if I draw a line through here, this would be considered our diameter. And the way we were just talking about it, we would start and be heading that direction. If we started right here on this positive side, if we consider this maybe to be an axis, we would be going in a counterclockwise direction. So how many diameters can wrap around a circle? So looking at this, if we took this original equation right here and we just solved, pi would equal, and in this case, I would have to divide c, the circumference, by the diameter here. So what it's saying is taking the length of the diameter, in this case, this length from here to here, laying it down on any point in the circle, but we'll start right here. If I were to lay that length, that diameter length, down and go in a counterclockwise direction, if I lay it down, I'm going to find out that I'm going to get like maybe over to here. And if I took another one and I laid it down, it would take me somewhere to like here. And then if I took another one and laid it down, it would take me right about here. And what it's saying is that it would take, how many diameters can wrap around a circle? Well, it would take 3.1415 diameters, or in this case, pi. So how many radii can wrap around a circle? Well, that would be 2 pi. And that's why the distance around the circle is 2 pi if we're talking about radians, because obviously the radians would be a shorter measure. You'd have to do twice as many of those. That is why there are always 2 pi radians in a circle, but we use this term as a unit that measures an angle, not the arc length or circumference. The arc length is measured in terms of a measure of length such as inches or feet, but the angle is measured in terms of radians. So, what is the possible conversion factor we can use to convert from degrees to radians? Well, we can do this one of two ways. We can either multiply by, in this case, 2 pi over 360 degrees, but that really simplifies down to pi over 180. So in this case, you would want to use that particular one. It's saying convert each to radians. So we have 180 degrees over 1. We're going to multiply that by pi over 180 degrees. The 180 degrees are going to cancel out, and we're left with an answer of pi. And if we think about it, that makes sense. If we have a circle and it's 2 pi around the circle, well then halfway around the circle has to be pi. So pretty quick, straightforward reasoning for that one. The next one, it says negative 27 degrees. So what are we looking at in terms of a negative 27 degrees? Well, we'd start with that same idea. Negative 27 degrees over 1 times pi over 180 degrees. Now, the degree symbols are going to cancel each other out. So now it just becomes a process of simplifying here. If I'm looking at this particular one, it looks to me like 9 would go into both numbers. 9 would go into this one 3 times. 9 would go into 180 20 times. So we would have the following answer. It would be negative 3 pi over 20. That would be the conversion. If we look at the next one, 105 degrees. So 105 degrees over 1 times pi over 180 degrees. The degrees are going to go away. So in effect, when you're doing these, you don't really need to write the degree part of this down. It should just come out. But when you're converting back, you may want to think about that. I just need a number here, something that will go into both of these numbers. I know for sure 5 would go into it. I'm looking for another number. To me, looks like 35. 35 would go into the first one. 35 would go into the second one. I don't know if that's 35. So simplifying, use your calculator. It'll do the work for you. But remember, you got to write your answer in terms of a fraction. I'm just going to take 5 out of this one. That's 21. 5 out of this one is going to be 36. And then I'm looking, okay, 3 would go into both of those, so this is 7. 3 goes into this one, 12. So this one's going to say 7 pi over 12. Like I said, if you're not sure about those, your calculator will do the work. Just keep in mind, something that you should be able to simplify a fraction. This next one, 57.3 degrees, and we want to convert this to radians. So how are we going to convert this to radians? Well, we're going to have 57.3 degrees over 1 times pi over 180 degrees. Keeping in mind that this is nothing I can really simplify with that decimal, so I would be saying it's 57.3 degrees pi over 180 degrees. The degree symbols are going to go away. I'm going to be left with this, but I can't leave a decimal like this. It doesn't work like that. So the way to deal with this, move your decimal one place to the right, and then you're going to move this decimal one place to the right. And then you can simplify this. If you do this in your calculator, it should be pretty quick. But simplifying this one should give you 191 pi over, looks like 600. In this case, how am I doing that? Well, if I look at the numbers here, quick trick for finding numbers that work. If you were to take all three of these numbers, 5, 7, and 3, and add them all together, and then divide by 3, if you come up with an even number, it should work. Well, 5 and 7 is 12, plus 3 is 15. 15 is divisible by 3, so 573 is divisible by 3. And then looking at this one, I know 1 and 8 are going to give you 9. 3 is divisible into 9, so it would also be divisible. The other way to do this, just in case you didn't know, take your calculator, put in 573, divide that by 1800, and then you're going to go to math, and you're going to go to fraction and just hit enter. It'll show you fraction, and then when you do this, it's going to give you the simplest version of that fraction. So handy calculator trick for you. That should work, and it should have worked even with the decimal equivalent, so keep that in mind. On to the next one. Now we've converted, in the first part, we converted to radians. Now we're going to convert to degrees. Well, it makes sense that if we're going to multiply here to convert from radians to degrees, then we would do exactly opposite of what we did in the first one. So 180 degrees over pi. So if I take this first one, it says pi over 4. And I'm going to multiply that by 180 degrees over pi. Well, pi's are going to cancel. And then it's just, what does 4, when it divides in? Well, 4 divides into 18 4 times, carry a 2. 4 and a 20 makes 5. So this is a 45-degree angle. And as we go further, you guys are going to hopefully learn to recognize ones that look like that, because that is one that's on your unit circle. So you should be able to recognize that fairly quick. The next one, negative 4 pi over 3. And we're going to multiply that by 180 degrees over pi. Pi's are going to cancel out. 3 divides into 180, 60-degree times. And then we're going to multiply 60 by this, negative 4, that's a negative 240 degrees. That would be our answer to this one. Now, the next one, 2.7. I know this one looks weird. 2.7 over 1 times, oops, I don't want to do that. Let me change colors real quick. 2.7 over 1, we're going to multiply that by 180 degrees over pi. Now keep in mind, 2.7, this is really a radian measure. It's not saying that it's pi. It's basically saying, like, if I took pi and divided by some number, I would get 2.7. So it's just doing the actual division part of that already and just stating it as a decimal equivalent. Because it's a decimal equivalent, we are going to actually just state the answer as a decimal equivalent. So taking my calculator, I'm just going to say 2.7 times 180. And then I'm going to divide that by pi. And there's a button for pi. It's right here on this little caret symbol. And when I do that, I get 154.69. When I round that to one decimal, I'm going to get 154.7. And this is in degrees. Keep in mind, you need to make sure you are stating degrees if that's what you're looking for here. So the arc length is radius times the angle measured in radians. This equation right here is something that you're going to need to know, so make sure that you keep your eye on that one. That will be something that will come back. Always remember the angle must be in radians when using this formula. So find the length of the arc of a circle of radius r intercepted by a central angle of theta. And here they're saying for number 8 that your radius is 2.2 centimeters and that your angle measure is 2 pi over 3. So according to the equation, we would take 2.2 centimeters, we would multiply that by 2 pi over 3, and we would get an answer. S is approximately. And then we'd take our calculator out and we would put this into our calculator, and we would end up getting an answer that says 4.6, roughly, if we're rounding to one decimal, centimeters. So that would be the arc length given the data that they've given us. As we go further, we're going to see where 2 pi over 3 is on a circle, and then you'll get a better idea here of what that arc length looks like. For the next one, it's saying that r is 14 inches and our theta is 4.2. So S is equal to, in this case, our r is 14 inches, and we're going to multiply that by the theta, which is 4.2. Now keep in mind, up here it said that the angle must always be in radians if you're going to use this formula. Well, this measure, it doesn't have a pi value, but as I explained before, this one is in radian measure, 4.2. It's just telling me how far around the circle I'm going. We calculated out. Instead of saying 2 pi over 3, we could have done the work and given an answer. That's all this is saying. This is radian measure. So 4.2. We do the work here and we round to one decimal. This would be approximately 58.8 inches. That would be our arc length. The next one. Example number 10, we're talking about the radius being 7 feet and the theta value being 117 degrees. Well, now this is in degrees, so we need to convert it to radians before we can do this. But we can do it all at once. S is equal to, this is 7 feet, and we're going to multiply that by 117 degrees. And then when I convert this, I got to convert it right here. So I'm going to convert it by saying pi, I'm going to multiply it by pi over 180 degrees. And then I'm going to do that math. So if you were to plug this in your calculator, just so we can see it, I would be saying 7 parenthesis, this is 117 times pi, second, and this thing, and then divide that by 180. And it should give us an answer. We round that off. It's going to be 14.3. So S is approximately 14.3 feet. hopefully we see how that works. Pretty straightforward. I don't see there's really a problem there. Moving on to this next part. The formal definition of a radian is as follows. The angle measure, which would be radian measure, is equal to these same two values of S and R here. It would be the arc length, the arc length divided by the radius. So, answer always comes out in radians in a problem like this. This would be another formula that you want to keep your eye on because you're going to need something like that. So these are saying, find the radian measure of a central angle of a circle of radius r that intercepts an arc length of s. So looking at this first one, theta, we're looking for the theta here. And if we think about it, it's telling us that we have a couple of different things. First of all, if I were to just draw a picture here, it says we have a radius of 12 inches. It says we have a arc length of 24 inches, which puts me somewhere over here, somewhere out in here. This would be 24 inches. So what we're looking for is the angle measure that's created right here. I want that angle measure, that degree. In order to do that, we use the equation that they gave us. We say that it's 24 inches, and we're dividing that by 12 inches. Inches go away, we're left with an answer of 2, and this is in radians. Hopefully that makes sense. This is 2 radians. So what do I mean when I say 2 radians? And maybe now's a good time to discuss radian measure, just because this word is kind of new and I think it's important that you understand it. What a radian means is if I took the radius and I lay it down on the circle, how many times would I end up doing something like that? 1 radian, so just so we're clear, 1 radian is equal to approximately 57 degrees. It's a little more than that, 57.4, 0.3, somewhere in there. And all it's saying is that it makes sense. We talked about the diameter earlier being where it was. This would basically be 2 in terms of radians, but it's really 1 diameter. So 2 radiuses get me to that point. That's what radians are talking about here. So hopefully that makes sense here. This idea of a radian measure, this is 2 radians or 2 radiuses. That's what we're looking for. Let's talk about this next problem. On the next one, it says that r is 3 meters and the s in this one is 1800 centimeters. Well, theta, if we have an r, here's my picture and here's my r, and it's 3 meters long. Well, 18 centimeters, that's going to be tough to lay that one down, our arc length. But if I change this from centimeters to meters, hopefully we understand that this would be 18 meters. So because it's 18 meters, when we draw this one, you'll see what I'm talking about in just a minute. Remember, that's an arc length here. So if we have a radius of 3 meters, how many radiuses would I have to lay down on this circle to get to 18 meters? Well, that makes sense. 18 meters divided by 3 meters, that's going to give you 6. This is 6 radians, which means it would put you on your circle, you would be roughly right there. It would go all the way around to that point. Hopefully this is making sense in terms of our arc length here. But our angle measure would be that long. So it'd be just short of 360 degrees if we're talking degrees. Now, this next one says, find the degree measure of a central angle of a circle of radius r that intercepts an arc length of s. So, r is equal to 11 meters, and s is equal to 286 meters. They want us to state the degree of this thing. Well, keep in mind then, first thing we got to do is find the angle measure in radians, and then once we find it in radians, we can convert it. This is 286 meters. We're dividing that by 11 meters. Meters cancel out. We're going to be left with an answer of 26 radians. But I want to get this in degrees, so I'm going to say 26, and I'm going to multiply this by 180 degrees over pi. And then I'm going to do that work. In this case, it's going to say, and I did this prior, it's approximately, 1489.7 degrees. So what does that mean for our picture? Well, if I start right here and I draw my starting position, and then I'm going this direction, I would need to figure out how many times it's going to go around. Well, if I take that number and I divide it by 360 in degrees, it's going to come out to roughly 4.14, I believe. Actually, is that about right? Somewhere in there. Which tells me then it's going to go around the circle 4 times and have a little bit left over. So it would be something like this maybe. And then you would start and you'd go around once, twice, 3 times. You got to go to at least 4. So starting here, there was 1, 2, 3, 4, and then that little bit extra. That's what we would draw it as if we were drawing a picture, showing how many times it's going to go around till it gets there. But roughly 4.4 times. All right, important formulas to remember, or ideas to remember. 2 pi radians in a circle of any size. A radian is the arc length divided by the radius, which is a way to measure an angle. Definition of radian, S over R. To find the arc length, you're going to use S is equal to R times theta, which is the angle measure. To convert from degrees to radians, multiply by pi over 180. To convert from radians to degrees, multiply by 180 over pi. And the meaning of pi, C over D. Hopefully this all makes sense. We will talk to you tomorrow. Bye.